Good afternoon, everyone. I'm Jun Wang from Curtin University, Australia. This paper comes from a PhD student's first year study. And we aim to develop a vision-based automatic approach to measure the scaffold productivity. So why we choose scaffold? I think the first easy reason is because this research project is sponsored by a scaffold vendor named Kifa. The second key reason, I think, is the importance of the scaffold in oil and gas industry. So in Western Australia, there is a huge demand of scaffold at both construction and the maintenance stages. So just give you an example, in a typical, I think the major plant shutdown project, the overall duration is around 28 days. And each day will cost $2 to $3 million. So you can guess how many days needed to erect and dismantling this scaffold. 6 to 7 days. Yeah. So the client said if your team could save 1 or 2 days, they can save lots of money. Well, so indeed, in the last 2 or 3 years, our team had developed several innovative solutions. Like we use BIM to improve the scaffold design. For example, they already have the 3D plant model. So if they want to replace this pump, they just click this pump and select a specific scaffold type. And then the scaffold will be automatically generated, and also the quantities. Yeah. So we develop a very detailed 4D BIM simulation to help the site workers to know how to erect this scaffold, yeah, safely and efficiently. And also, even we create some virtual visual work package, so the site supervisors and also the workers can follow the schedules, to improve the productivity. But I think the clients still want to know what happened on site and what's the real productivity of the scaffold workers. So, and also I think another reason is why we choose scaffold is the high cost. So I can give you 2 numbers. So the hourly rate of a scaffold worker, on-site scaffold worker in Australia, is around 120 Australian dollars. 120 Australian dollars. So for research staff with a PhD degree, in university, is around 50 Australian dollars. So sometimes, I want to resign my current job. I want to work as a scaffolder because I can, get more money. Yeah. So let's look at the current method for measuring the scaffold productivity. So they will employ a third person, on site to watch and to record the time of the site workers, to erect and dismantle the scaffold. So we know, it's manually and time-consuming, inefficient, and also not accurate enough. So in this research, we try to use, we try to leverage the current videos. We try to develop algorithm which can help us to recognize the posture of the scaffold workers and also automatically calculate the productivity for the clients. These 4 are the currently, I think, the popular method used for activity capturing. We choose the final one. I think the key reason is the final one is very easy to be implemented on site. So sometimes from the academic perspective, they want to improve the method as accurate as possible, like even 100% is accurate. But for the industry partners, for the industry people, sometimes they can sacrifice the accuracy. If one method can be very easy to be installed on site. So that's why we choose the video, the CCTV. This slide shows the the whole idea. So these on-site videos will be firstly imported into the video processing platform. So this platform is developed based on open source toolkit. Someone had already invented that. So it's named OpenPose. So we use this one as a basis. And then I think after the video processing platform, we can get the 3D vector of the human postures. So our focus is not the algorithm. Maybe in the future we will use another open source toolkit if that one is more accurate than this one. So our job is to do the activity definition and classification. Because from a lean perspective, the activity can be divided into 3 categories, like the value-adding activity, non-value-adding activity but necessary, and the waste. So for scaffold construction, I think the fixed coupler is the value-adding activity, and the component moving, like you move the tube, is the non-value-adding but necessary. And the searching component, if you want to find where is the component, and also you're just waiting for the materials, I think that one is the waste, non-value-adding activity. So following this protocol, I think the activity in this research is classified into effective activity, the contributive activity, and also the ineffective activity. So we try to use the different classification methods like the SVM and the KNN to classify the 3D vectors. So this slide shows our current progress. I think right now we can only successfully recognize one type of effective activity. I think the fixed coupler, only this type of action. So in the future, we will try to continually improve our classification algorithm and also try to recognize the other 2 types of activities so that we can calculate the productivity. So in terms of productivity measurement, there are 2 types of approaches. The first one is based on time. So if we can have the time of the effective activity and the contributive activity, we can add these 2 and divide it by the total duration. The second approach is about I think it's calculated based on the quantity. So how many numbers of couplers or scaffold installed in a specific time t, and then we can calculate the scaffold. So we don't know which one is better, because we still need to discuss with our industry partner. And we don't have a conclusion in this slide, because we put that part, I think, in the next year ConVR. So feel free to attend the next year ConVR, and we can share you more information about that. So yeah, that's all. Thank you.